This is just a video to show you how to get the coefficients needed for building a mediation model using SPSS as opposed to using process. Okay, so here is a nice little picture of our model, which should be familiar by now. On the top, we've got just the bivariate association, your IV to the DV. Down the bottom, the mediated model with the indirect pathway, AB, going through the mediator. Okay, so we're going to just go through the analyses that give us the coefficients to put onto this model. So we're going to look at path C up the top, which is simply done by bivariate regression, predicting the DV from the IV. That's that one there. Then the next one we want to look at is path A, and that's down there. And to do that, we do the bivariate regression predicting the mediator from the IV. So the mediator gets entered as the dependent variable in a regression analysis, and the IV is the IV, and that'll give us that one there. Okay, and then the third one that we want to do, third analysis, is a multiple regression predicting the dependent variable from the mediator and the IV. So the mediator and the IV go in as independent variables, and the DV goes in as the dependent variable. And that's going to give us the coefficients for these two paths. Okay, so these ones there. So we're going to, the reason we do multiple regression is the coefficients for one IV in a multiple regression indicate the association between that IV and the DV when all other predictors in the model are held constant. So that's going to give us, if we put the IV and the mediator in as predictors for the DV, it's going to give us the unique association between the IV and the DV, which is to say the association between the IV and the DV when the mediator is held constant. That's path C dashed. So IV to DV controlling for the mediator. It will also give us the same analysis, path B, which is the association between the mediator and the DV when the IV is controlled for or held constant. Okay, so when the analysis the IV explains is partialed out. That's going to give us path B. So a multiple regression done that way will give us those two pathways there. Okay, now got a tiny little note there. Yes, there are other ways to get these coefficients when they're bivariate. You can get them just from correlations. You can do this more efficiently if you do a bit of a hierarchical thing, but if I spell it out like this, it's much easier to follow and you won't go wrong if you do it this way. If you can find a more efficient way to do it and you get the right numbers, that's fine. But this way works and is easier to explain. So let's now go ahead and get those coefficients by running this in SPSS. Okay, so we're going to put that over there. Okay, so now we're going to go and get SPSS and get our coefficients. The model we're going to do is the same one we did in the tutes, which is got family history as the IV, word reading as the DV, and cognitive skills is our mediator. So the idea is that family history has an impact on word reading, but it's not direct. Family history impacts cognitive skills, and then cognitive skills impacts word reading. Okay, so we've got some spaces there. We're going to fill in the blanks by using SPSS. Okay, so now we've got SPSS here, and we're just using the same data set from the tutes. So we're going to go and run that first required analysis. So we want a regression, and we're going to put the DV in as the dependent variable, so that's reading skills, and we are predicting the DV using our IV family history. Now we don't need much here. We'll just do that. Can't help myself, we'll get that as well. You really just need the basic stats any regression would produce. So we go ahead and run that. And here we have the regression output. And if we look at the model summary, really doesn't matter which ones you use, but the coefficients is probably the best one. You'll notice there 0.227 minus 0.227. So that goes on our model, okay, for path C. Because this bivariate regression, path C right there, so it's minus 0.227. The next one we want is a bivariate regression predicting the mediator from the IV. So we do another one. This time we're predicting the mediator from the IV, so not the DV. Cognitive skills, which is our mediator. So we just run that regression, and you'll see there we get a beta of minus 0.239. Okay, so that's the coefficient that goes for path A. Path A, bivariate regression from mediator to IV. That's this analysis here. We put that in there for path A. Now our third analysis is path B and C dashed, and we get that from a multiple regression predicting the DV from both the mediator and the IV. So we go back again, and our mediator comes out from where it was in the dependent variable and goes down here. It's one of the IVs. These are the predictors. And our dependent variable is word reading skills. That's our DV from our model. So we've got the DV word reading, and the two predictors are family history over here and cognitive skills here, both predicting word reading. And we just run that analysis. And there we have our two coefficients, minus 0.101 and 0.529. Okay, so those are the coefficients that we need in our model. And that's all the coefficients that we need. Okay, so you can see here that we now have, one other thing we wanted was a total of path AB, which we get by multiplying the coefficient for path A by the coefficient for path B, and our result there is minus 0.126. That's our path AB coefficient. Now we don't know whether it's significant. We don't have a test for it yet. Could use a Sobel test. We can also do bootstrapping. That's for another time. This is just about how to get these coefficients. Now we did this table in the tute, but it's produced exactly the same way. So our three required analyses for path A, B, and C are what we need to fill in that table as well. And you can see the beta value in this table is the same beta value that's down there because it's for part C. And we got that by doing this analysis. So that analysis, I'll just go get the Spss output. Okay, so here's the Spss output that we just produced. And you can see here that we've got, if I look at the first analysis that we ran up here, if I look at the coefficients table in that analysis, there's our minus 0.227, and here are the other numbers, minus 27.16, standard error, confidence intervals, and if I scroll out, there's my semi-partial, which I can square and get that 5.2%. So these numbers all come from here. Okay, and if we continue down, our next analysis, there's the beta. It's there on path A. So this is path A, our analysis for that, which was produced by that, and looks like back in SPSS, I can scroll down to the second analysis and to the coefficients table, which is here. There's our beta value of minus 0.239, and here's all the other numbers that we use to fill in that line across there. And the R squared comes from the model summary at the start of that regression. So that's our second analysis. And the third analysis gave us both of these two beta values, and they went onto those lines in the model. And that was one analysis that gave us both part B and C dashed, and it was that analysis there. So it's just those three analyses that get us all the numbers that we need. Okay, and I'll show you that in SPSS. So in SPSS, if I look at the third analysis that we ran, that was our multiple regression with the two IVs predicting the DV. Go down to the coefficients, and here are the beta values, and here are all the other numbers that we used to fill in that table. So it's pretty straightforward. Now, this table up here, this table 4.2, I don't know that you would ever actually report that. Maybe you would if you like it and you find it communicates things easily. I kind of like the figure with just those coefficients on it. It's cleaner, it's simpler. It's a nice job. You'll find there's one just like it in the APA manual, and it comes from an article by Michelle Hood, Liz Conlon, and Glenda Andrews. So people were impressed at how they wrote that up. Okay. The only other thing to mention is that we also put in that table a beta value that we produced by multiplying those two beta values. But that's the only part of that line we can fill in yet. Process is going to allow us to fill in all the rest of it, and we'll have a look at process some other time.